Imagine your CPU is a busy chef, chopping vegetables, cooking, washing dishes, all at once. DMA is like hiring a kitchen assistant who can move the veggies from the fridge to the counter without bothering the chef. In computers, DMA, direct memory access, moves data between memory and devices without asking the CPU to carry every byte. Let's take an example. You've got an ADC, an analog to digital converter, measuring a sensor's voltage. Normally, the ADC sends that data to the CPU, and the CPU writes it into memory. But with DMA, the ADC sends it straight to memory, skipping the CPU's desk entirely. Same goes for other peripherals, like reading data from a serial port or storing audio samples from a microphone. DMA can also handle memory-to-memory transfers without the CPU micromanaging every step. So why use DMA? First, throughput. DMA can keep the data flowing without pause, even when the CPU is busy with other things. Second, lower CPU overhead. Since the CPU isn't moving every byte, it can spend time on more important tasks, like running algorithms, handling user input, or playing solitaire. The result? Faster, smoother performance, and fewer data traffic jams inside your system. Of course, DMA isn't magic fairy dust. It comes with caveats. First, cache coherency. If your CPU uses a cache, DMA can write to memory behind the CPU's back, and the CPU might still read stale data from its cache. That's why we need cache management steps before and after DMA transfers. Second, complexity. Setting up DMA requires configuring channels, priorities, transfer sizes, and sometimes interrupts. It's not as simple as calling copy data. Here's a quick example. You want to continuously read a temperature sensor with an ADC and store the readings into a circular buffer in memory. Step 1. Configure the ADC to sample at a fixed rate. Step 2. Set up DMA to transfer each ADC result directly into the buffer. Step 3. Enable DMA interrupts to signal when the buffer is half full or full, so your CPU knows when to process the data. Now your CPU is free to handle other tasks, like sending readings to a display, while DMA quietly streams ADC data into memory in the background. That's the beauty of DMA. It works silently, tirelessly, and lets your CPU breathe.